Today we're going to talk about building an accessible classroom with 3D printing, and we have a number of experts joining us on the call. As you can see from the agenda, I'll do some quick introductions. So as I said, my name is Lisa Waters-Verne. We're going to listen to Dr. Ting Su, a TBI and an educational consultant, discuss a project that she worked on that really was the introduction and the start to all of our 3D printing work. I will return then to talk about a grant that we received from the Institute of Museum and Library Services. Lucia Hasty, who is a retired teacher for the visually impaired and has experience with other disabilities, including learning disabilities, will be talking about when and who we should be printing for. Next, we're going to hear from Kevin Yang, a student at Stanford and the founder of Library Lina. Library Lina is a repository of files that is working on getting 3D printing into every classroom. And then last, we're going to talk to Abigail Stengel, who has a master's in information communication technology for development, and is currently a doctoral student at the University of Colorado Boulder. She focuses on multimodal communications and tactiles. So we're very honored to have all of these experts joining us today. We're going to reserve questions for the end, so if you have any questions, feel free to write them into the chat box, or we can wait to the end and address them at that point. So with that, I want to introduce Dr. Ting Su. Oh, I'm sorry, one more thing before we get there. Some of you people who are on the call might be new to 3D printing, and I wanted to just spend a moment to talk to you about what is 3D printing and why it is important. 3D printers have shown up in many classrooms, many schools over the past few years, and as prices of printers are going down, we see more and more access to printers. However, many people don't necessarily understand the process. So 3D printing is essentially 2D printing on top of each other. It's a layering process. And you can use different materials, such as rubber, metal, plastic. You can even use hot cocoa powder and Nutella. So, as 3D printers emerge and grow, we're seeing different ways to get 3D printed tactiles into in different forms. And why is this important? Well, it's mainly important because it's another way to access multimodal information in the classroom. We all know that images are complex and that teachers often create their own. For teachers who have to create multiple files that are exactly the same, 3D printing offers a solution to have the exact replica available for all the students in the classroom. And so I briefly introduced Dr. Ting Su, but I'm going to turn it over to her at this point, and she can tell you about the project that she worked on with Benetech to get all of this started.
Okay, thank you for the introduction, Lisa. So as Lisa mentioned, we carried out some initial research in the field, basically because we were hearing a lot about 3D printing, people were seeing it on social media, and the question was, what does this mean for delivering accessible instructional materials in the classroom, specifically for students with accessibility needs? So the research was carried out between fall of 2013 and spring of 2014, and it included a survey from about 163 people and 17 interviews from stakeholders. And these stakeholders included about 90 TVIs, teachers of the visually impaired, which was really exciting to me to see all these teachers of the visually impaired respond to the survey, as well as other alternate media and other accessibility specialists. And we also were able to get in touch with a few students with accessibility needs who had also had some feedback to provide about 3D printing. So if you're interested, you can check out the Diagram Center website where you can read the full report on the research that was carried out. And there's also a link to a webinar that we gave specifically on 3D printing for accessible instructional materials. So from this research, we were able to identify a few advantages of this technology. I think that one of the greatest advantages is that when 3D printing is implemented to supplement existing learning media, it was found that it could enhance the learning or engagement of all peers in a community. And I thought that was really neat because oftentimes our students with disabilities end up being sidelined or isolated in the classroom as their accessibility needs are addressed. Another example might be areas in the community. For example, displays that are typically look but don't touch. These types of activities can become immediately interactive for any individual. So now, in addition to providing that accessibility for that student who can't see things behind the glass, all of the students in a museum tour group can be immediately engaged in putting their hands and interacting with these things that are also behind glass. Other examples that really engage overall interaction is, looking at microscopic organisms that are typically under a microscope, but when you 3D print it, it could be handled now. So this is a great advantage of 3D printing for hands-on learning. Another great advantage that was reported is that this technology can be used to fabricate models that were previously only imagined, based on these microscopic illustrations that people look at or have been described, or to replace parts that have been too costly to purchase or replace. So sometimes it might just be like a little holder type of thing that you want to customize for a person's own needs. Given that there are some advantages, of course, there's always going to be considerations in using any new technology with students or adopting any new technology in education in general. And the number one thing that is 3D printing really requires time and technical skill to learn how to use a printer, how to use the software associated with it, how to maintain a printer, and also, of course, how to troubleshoot issues that come up, because definitely this is a technology that has somewhat of a learning curve. Now, speaking from a teacher's point of view, I'm a teacher of students with visual impairments, so I'm going to speak from my perspective on this issue, is that we are all strapped for time and resources. I'm sure this extends to other people as well, particularly those who might have a larger learning curve than others in learning technology. Well, for teachers, we really need to be well supported regarding the ease of learning and using technology, but also we need to overcome barriers in just accessing the equipment itself and the files for printing, because as anybody knows who's tried out new technology, part of that learning process is that play aspect and kind of learning on the fly. Lastly, a consideration for 3D printing that I think is both an advantage and potential barrier to accessible learning is that, yes, this technology can be used by anyone, which can potentially engage community efforts to support all types of learners and accessibility. However, when designing for students who require certain pedagogical expertise, so basically knowing how students with visual impairments or how students with disabilities require differentiated instruction, it's really important to understand how these students learn, and then from that, choose the appropriate intervention strategies and ensuing technologies. So that kind of segues us to the biggest recommendation, which is collaboration. So in order to ensure that this technology is really appropriately used and applied for accessibility, it is so important to collaborate and build partnerships and relationships between technology developers, the teachers who can potentially use this technology to enhance instruction, to really loop in the special educators who understand the differentiated learning needs, and lastly, the community supports to leverage resources, which you'll hear more about later. So moving along, some of the things that could be identified through collaboration is to understand how 3D printing can fit in with existing tools for delivering accessible instructional materials. So on this slide, you see a photo of a cat, a line drawing of the cat, and sometimes these line drawings can be raised as a tactile graphic. And then other times you might see some pictures that have been 3D printed as sort of like a 2.5D representation. And finally, as a full-on 3D printed model of a cat. You can see with all these different representations of a cat, it may or may not accurately convey what a cat means to a student who is a tactile learner. The final picture is one of a duck, where the duck is represented by the elements that are very meaningful and representational of a duck. And this is a duck that's been constructed with felt, and there's feathers on the wings. And so if you think about what a kitty cat might mean to a kid who's never actually seen or touched a kitty cat, what might be the takeaway? It might be like having the whiskers or the tail versus, that raised line drawing is going to just look like a squiggly, wiggly, ovally kind of shape. So it's important to emphasize that spatial and not necessarily visual representation of information to really make sure it's meaningful to the person. And lastly, I feel like one of the biggest steps here is when we're designing for accessibility, it's important to consider the accessibility of the tools, including the devices and the software itself, so that child who is blind and interested in that microbiology lesson can start designing his or her own models to be fully engaged in that learning process. So I'm really excited to hear what other presenters have, but that's pretty much our main recommendations that came out of the research from our year 1 of this work. Thank you.
Great, thank you, Ting. And what we did after Ting presented her work is we really thought hard about, well, what is the next steps and where do we need to go? So in the fall of 2013, we were awarded a grant from the Institute of Museum and Library Services to think about how do these other communities fit into the conversation that Ting just told us about. And as you heard, collaboration is a big piece. So what we did this year is we pulled together about 50 people from across the country who were technologists, educators, users of tactiles, museums, libraries, 3D printing, and many other people to talk about 3D printing implications in the classroom. And what came out of it were a number of things. One, when we talk about 3D printing, we're talking about a number of things. There's actually the printing of an object, there's the design of an object to be printed, and then there's the pedagogy of how that object is used in the classroom. And our concern is more for that pedagogy piece. And when I say our, I mean the Benetech concern. But what we found were some really interesting things in relation to how museums and libraries fit into this equation. So many libraries have makerspaces, and a makerspace is a place where people can come with ideas and thoughts and use technology like 3D printing or laser cutting or wood cutting tools to create the things that they want, that they've envisioned and want to have in a 3D form. Since museums have many of these, what we found is for the short term, classrooms probably aren't the best place to be printing off 3D printed objects. Because museums have this technology, museums may be in the short run that place to do it. So we thought about a number of different directions to go beyond this and have come up with a number of pilots we want to pursue. And many of them involve having access to 3D printed tactiles in the classroom and requesting them through your library. So whether you're using an online hub to create something and then have a library print it, or if you're borrowing an existing object from a library in addition. But one thing I wanted to point out, and one of the biggest things that came out of this forum, was we developed a quick start guide to 3D printing and accessible education. And at the end, we can have the link available to you so that you can go in and find it. It's on the Diagram Center site. And what that is that's a really great place to start. So if you're an educator and you're thinking, I think I want to use 3D printed tactiles in my classroom, where do I begin? That's a really great place to go and to read and to think about the different considerations you need to have with identifying 3D printed tactiles for your classroom. Additionally, there's information in there for administrators, because the decision to have 3D printing in the classroom is not just, do we have a printer and we're going to print stuff, but there's different considerations that need to be there too. And then how do you work with libraries and how do you work with museums? So I talked briefly about working with libraries, but museums have a wealth of information available and a lot of content that's available. And so we feel that there are ways that we can work better with museums to get this information in so that kids have access to things that they might not see because the museum might be located 3,000 miles away. The last day of this event, however, was probably the most exciting day. We held what we call the Design-a-thon. It's kind of like a hackathon, but what we did is we paired designers with actual users of 3D tactiles. And they worked together to look for existing files that are on a number of free repositories around the world and modified them to match a biology book. So what we did is we took an open education resource biology book and identified about 100 objects that would be good candidates to have 3D printed objects or representations for. And as I said, some of these objects exist already, but not all of them are in a form that actually meets the needs of the user. So I'm going to give you an example real quickly of one of the users who was there to help us with this. Chelsea Cook is a student, at the time had just graduated from Virginia Tech, and she studies astronomy. she worked with one of the designers on an existing plant cell. When we printed the cell, she had noticed that there was a lot of information on that cell, and it was a little too busy for her to actually access this information. She and the designer were able to find ways to minimize some of the information that was available there and create an accessible plant cell for students with visual impairments that would still have all the relevant information, but were able to remove the extra static if it were. And so we continue to work on things like this and projects like this and building up a repository as well of these accessible objects. So as the months continue, we'll have more information on that. But for now, we wanted to just make sure that you were aware of the things that came out of our forum. And so my next slide is actually a transition into Lucia, but not everything needs to be printed. And as you saw with Ting, when you're talking about a cat, there's different ways you can represent that cat. So one of the quotes we like to use around here is, if something's too big, too small, too fragile, or too dangerous, that might be a good candidate to print. Something like a scorpion, maybe not something you want to have in your classroom. But if it's something like a cow, does it make sense to print that cow, or does it make more sense to have the kids go actually visit a real cow? So with that, I want to transition over to Lucia. Lucia, are you on mute? Lucia? Did we lose you? So I'm going to recommend that we skip ahead, and then when we reconnect with Lucia, we can come back to this. But as I was saying, in addition to the Quick Start Guide and the repository that came out of the forum, we also were able to initiate a number of standards groups. So I'm going to skip to Kevin real quick and have him talk to us about some of the standards groups that were created as a result of the conference.
Awesome. So we have two main standards groups that were created, the standards group itself and then the mandated group that would help implement the standard. So I'm going to talk first about why we actually need standards. So, one slide. All right. So we were thinking about how we can improve the 3D printing experience, and we realized that standards was a good way. The 3D standards would save time, resources, and facilitate the design process for designers. Without standards, for example, when a teacher finds a 3D model that he wants to print, he can't be certain that after 3 hours of 3D printing, he will get a usable model. With standards, though, models like these that are poorly designed will be weeded out. So when teacher wants to go print something, he knows that what he gets will be good. Any user who prints a 3D model that meets standards will be assured that the 3D printed model has been tested by 3D printing and being used in the classroom. Furthermore, 3D printing standards will facilitate the design process for designers. So a lot of the 3D designers that I've been working with don't have firsthand experience with visually impaired students. So it's hard for them to actually empathize with the needs of the user. So sometimes they create models that have Braille that's irregular size, or the features are way too small for them to actually feel and use it. Standards would help them design useful models by providing these guidelines so that when they go out and design, they know that they're designing something that would be useful for the end user. And standards are really important, so we've proposed a way to implement it through metadata that would go under each model. So this implementation through metadata would include all these lists of things. So first it would be best type of 3D printer. For example, like an FDM 3D printer that melts plastic or an SLA that uses lasers, so you can determine which one's the best for that model. So the teacher knows that when he wants to print the model, how he should go about doing that. Furthermore, will give out recommendations. So for the teacher who doesn't want to spend so much time learning 3D printing, because the learning curve is very large, we'll provide all of the stats that he would need to know to print the best model. For example, if he would have to set the hot bed to a certain temperature, he wouldn't have to search for that on the line. It would already be inside the metadata for the model. It would have the creator and the license to be sure that we give credit to who created it. The intended grade level. So this part is very interesting for this type of 3D model. Because this type of 3D model is specifically meant for the individual who is visually impaired in learning, we include like the grade level. So we can say this model would be useful for this set of grade levels, so that we don't have overly complicated models for lower grades or vice versa. It'll have a link to STL, so someone finds the model and they find just the metadata through Google, they can always go to that STL. And this last part is really cool. Propose a tour of how the person would use the model. So we want one teacher to first use it, and then how they use it in class, they would write a little summary onto the metadata so that other teachers, when they decide, hey, I might want to use this for my class, they'll be able to read another teacher's experience and see that they can use it and see maybe different ways that other teachers have been using the same model. So where are we right now? So we're in the investigating phase. So we have two subgroups, the 3D printing standard subgroup and the metadata subgroup. Both of the groups are currently investigating current implementations in the world. So there have been metadata like the diagrammer, for example, but nothing specific to 3D models in the realm that we're looking for. So we're currently learning about, for standards, we're currently learning about standards for 3D printed tactile objects, not 3D printed, tactile objects, and we're seeing the different issues that you can have for a 2D tactile, and we're trying to translate that into a 3D graphic. Yeah, so that's what we're doing on these two subgroups.
Great, thanks, Kevin. And that's actually, this is a good transition back to Lucia. I think we figured out our technical issues. So let me get her slides back up, and she's again going to talk about the differences, because just because we can print 3D objects doesn't necessarily mean it's appropriate for all of our students. So with that, Lucia, can we hear you now? All right, so I'm going to start, and then as we get her on, she can jump in and add to this particular section. But as a piece of the Quick Start Guide that was created, we developed a matrix that really discussed when it's appropriate and for whom. Because if you think about a student who is blind or low vision, their needs might be very different than a student with a learning disability who is also a tactile learner but can see other nuances that a person without vision may not be able to see. So when we're thinking about students who are blind or low vision, it may be appropriate to print a 3D model if the actual object's not available. Something that shows process and stages and progressions. So we may be able to use a chart in a book for a sighted individual that shows the differences of the 9 stages of fetal growth, but someone who might not have that visual experience to be able to understand how the pieces go from one to the other might benefit from something that is 3D printed so that they can actually experience each of those in the stages. Or things that are movable or have removable parts. So when you're thinking about like a knee joint, something that is static might not be as useful to this population as an object that actually bends and moves so people can understand how the pieces come together and where they move. It does not support, 3D modeling does not support learning when it's a standalone source of information. So to just hand a student who is blind or low vision an object and say, okay, now what is this, is not going to be something that is going to benefit them necessarily. There's context that's needed to go around the objects. There's orientation to make sure that people understand which side's up, which side's down. So standalone only will not be there. And then the other thing is when attempting to duplicate a 2D image. So sometimes 2D representations truly are the best way to communicate information to this population. You may or may not use a 3D printer to get a 2D image, but there are other ways like flash paper and other ways to make 2D tactiles that could be more appropriate. And then the other thing is, oftentimes when we print on a 3D printer, we're essentially printing 2.5D. So they're still flat things. So if you think about printing a map is truly not a 3D image because it's still flat with the 2.5D raised representation. When you think about 3D, really we're thinking about things that are being seen in all 360 degrees. So for students who are deaf and hard of hearing, when would we want to print? So again, we'd want to print to support learning when the learner also has a reading deficit or difficulty in understanding written material, or having an actual object in hand will help benefit and enhance that learning opportunity. The learner has difficulty understanding sign language or the interpreter's explanation, or if the learner's first language is not English. So again, having that multimodal access to the same information might be a way to get that information across to a student who is deaf or hard of hearing. And they do not need 3D modeling when the particular learner has the same access to an object as the other students. So if the object is a visual representation and they're able to see it, they most likely would be able to get the same out of their other sighted peers. When thinking of students with learning disabilities, oftentimes, and I think Ting had pointed out in her piece of the presentation, we think about 3D printing and having these representations available for students with visual impairments, but what we're learning as we do more of this work is that many other students, especially students with learning disabilities, also benefit from having access to objects. So if a student has a visual processing difficulty and they need the hands-on experience to understand an object, a 3D printed tactile may be a good solution. Also, students with auditory processing difficulties who need to examine things a little closely and ask questions while putting their hands on an object might also benefit. But when it's not appropriate then would be when the object's not available for close-up examination or manipulation. So if it's not adding any additional information to what they're currently able to access through an image alone, it would not necessarily be a good solution. So for our last group, physical disabilities, you may want to consider using a 3D model to support learning when the actual object or parts are not accessible for viewing. So someone, again, who might need access to the actual physical model. And then when the technology is too difficult for motor abilities. So thinking about the student and are they able to access the information in the current form is a consideration to think about, or should we have something where they can actually put their hands on something to manipulate it? And again, when the object's not available for examination or manipulation, then a 3D printed tactile may not be appropriate. So now I want to jump real quickly over to Abigail Stengel, who's going to talk to us about some projects that they're doing at the University of Colorado on their tactile picture books.
Thanks, Lisa. Can you hear me?
Yes, we can.
Okay. So it's great to be here, and I am representing my team at the University of Colorado. Dr. Tom Ye is my advisor, and my colleague, Toon Kim. And we've been taking a slightly different approach at investigating how 3D printing can be utilized to make tactile pictures and tactile graphics. Our approach really, since we are rooted in the Department of Computer Science, we have been focusing on looking at how the software and the 3D printing hardware can be used and the thresholds of these different technologies. And we've been conducting research through method called design research, where essentially we are using 3D printing printers and modeling software to help us explore the issue of, how do we make accessible materials. And the two images on this slide are of an early effort of ours to, number one, understand the feasibility of 3D printers to create 2.5D relief images. And we used some samples we were able to easily create and disseminate as design probes and as a way to understand what stakeholders care about when thinking about 3D printing pictures. So the results of this research were really starting to understand who is interested in using 3D printing for the development of accessible tactile graphics and pictures. And we had a lot of scholars, a lot of parents, librarians, other individuals out to obtain samples of this. Second research project that I want to talk about today really looks at what distinct stakeholders are interested and willing to contribute to developing 3D accessible tactile books. And then how exactly can these stakeholders be leveraged to increase the supply of accessible materials. And so in this research, we conducted a series of 8 workshops with a variety of different stakeholders that contacted us with interest in our research. And these included accessibility librarians, children's librarians, library volunteers, engineers, interactive designers, and orientation and mobility specialists and teams of the visually impaired. And as we were working through these workshops, we noticed that there are a suite of skill sets that are required to create accessible tactile materials. Understanding about human development, understanding about literacy needs and age, understanding about graphicacy and tactile literacy, ability to task manage while using different 3D modeling programs, and then just the ability to model and manage the overall project. And so, as we can see in this graph or this table, which has essentially the hierarchy of the different groups and their skill sets, we saw that no group exactly overlapped sets. And in turn, we had really want to create modeling programs and support tools to help leverage those skill sets that they do have and communicate with each other based off their different skill sets. A third research project we've been working on is looking at how can we create digital fabrication activities to engage students in the creation of tactile and principles of universal design. So as we've heard, it's really important to make tactile graphics and pictures with a model of inclusion where the end users are involved in the design process and evaluating the materials that are developed. We conducted some research working in middle school classrooms and looking at various ways of introducing concepts of universal design and inclusion for learning. And I'll end by just talking about two quick resources that we're developing at the University of Colorado. One is a blog based off of our work and different findings that we have with experimenting with different materials. And we've this blog 3D Ally, da1y.info. And we're hoping to build the community of people interested in talking about and sharing information and ideas about their creative processes. And lastly, since we are based in the computer science department, we are working on developing a HTML-based syntax 3D modeling language, which is not currently accessible to some readers, but has the feasibility to be. So we're working on that right now. So thinking that HTML is a low threshold coding language, somebody may be able to use a screen reader and design and compose 3D tactile pictures with this CrossML program. Thank you.
Great, thanks, Abby, and that's a lot of really exciting work. So where do we go from here, and what do we need to do? The Diagram Center is going to continue working on 3D printing, and we have a number of projects in this next year that we're going to be focusing on. So what I would encourage you to do is, if you're interested in learning more about our 3D printing and our partners and how we work together with different communities who are working in the same area, I would encourage you to go to the Diagram Center Research. Also, you can follow Twitter on Twitter at DiagramC. You can also email us, and if you're specifically interested in 3D printing information, I would encourage you to email 3d@benetech.org. And so, as I said, in the next few months, we'll have some new interesting and exciting 3D printing things to report. But at this point, I think we'll open it up to some questions. So if there's anyone on the line who has some questions for any of the presenters, feel free, or if there's any presenter who wants to add something to what we talked about today, this is our opportunity. I don't have any questions coming in through the chat box, but again, if you're interested in anything specific that you heard today or that you'd like more information about, I highly encourage you to email us at 3d@benetech.org. And what we'll do is, if it's a specific question for one of our other presenters, we'll make sure we can connect with them and get you the right information. So with that, I thank everyone for joining us today. And for those of you who are local to Palo Alto or visit the Benetech offices, feel free to stop by and visit with me. I have a number of models that you can come and play with. And we look forward to talking with you again in the future. Thanks, everyone.